Hi everybody, let's talk more about the free radical addition polymerization. I want first to remind you that polymerization is a chemical reaction to form a polymer, and this can be by two main mechanisms, which can be addition or chain growth and condensation. One of the addition reactions is the free radical addition, and this is formed by the initiation of free radical formation. So this type of reaction usually occur in alkenes, in low molecular weight alkenes. This alkene is treated with a small amount of radical initiator. This radical initiator initiates and activates the process of radical free radical formation. And then this radical will attract more monomers to allow the chain, the polymerization to grow more and more until it is terminated. And the famous example is the polymerization of ethylene. We have three main steps. The mechanism of free radical polymerization has three main steps. The initiation, which is carried out by an initiator. The propagation, this is the longest step where chain is continue to grow in length. Termination is a process that stops the growth of the polymer chain. The initiation step, the first step in free radical addition polymerization, this initiation can be chemical initiation, thermal initiation, or by radiation. In chemical initiation, there is a chemical species used to initiate the formation of free radical, of monomer free radical. This initiator reacts directly with the monomer and they form intermediate compound, a free radical, that will attack more monomers. Examples of the chemical initiators are peroxides and aliphatic azo compounds like vinyl chloride. Also, Ziegler catalyst, which is an organometallic compound, and metallic halides such as triethyl aluminum and titanium tetrachloride. These are examples of the chemical initiation. The thermal initiation, from its name, it is a thermal decomposition of the monomer. Monomer is decomposed by temperature, like styrene. But the problem of this method of initiation that it can lead to undesired polymerization. So it can result in an undesired polymer. The inhibitors are used to protect the monomers before stored. So these inhibitors are scavengers of the radicals, which prohibit the formation of radicals while storing the monomers. Because if the monomer is stored, it can be decomposed by heat, by high temperature. In that case, a free radical will be formed, and this free radical will be active, and they can attack more monomers. And the monomers will be added to the chain, and maybe there is undesired polymer will be formed, like undesired chain length, for example. Undesired bonds will be formed, like if we need to form a polymer which is saturated polymer, but maybe there is unsaturated polymer that is formed, which can be a byproduct or undesired polymer. Initiation by radiation. This process, the initiator is caused by light. The decomposition of the initiator is by light. or another source of radiation. The problem here is that method is very expensive and it is limited in its application, so it is applied to the polymerization systems that operate at low temperature. That's because it's relatively high cost. So they limit this way of initiation for certain polymerization reactions, certain polymerization systems. After initiation, as mentioned, initiation, this is the step where the very first step where there is a free radical is formed. Where the monomer now is active, the free radical can attack more monomers. The way or the process of starting attacking more monomers, which means adding to the chain, this is called propagation. Propagation. There is when the chain is grow. This is the way of a chain growth procedure. This is the propagation. So this step is the longest step regarding the time. This takes the longest time during the polymerization reaction because it will allow monomers to be added to the chain until they are terminated. So polymer spends most of its time in increasing in its chain length or what is called propagation. What happens is after the radical initiator is formed, the intermediate compound, the intermediate free radical is formed. It is active, so it can attack a monomer. And in turn, it will be a longer free radical, which is active and can attack another monomer and become a longer, and so on. So the chain propagates until there are no more monomers. So the chain will keep growing up until there is no monomers in in the medium or until termination occurs. When the propagation is left until there is no more monomers in the medium, this is called living polymerization because the polymerization is alive as there is there is a monomer in the medium. This is what happened exactly. The first is the initiator, the periodical. So it attacks and attracts one monomer, and then the free radical is transferred to the last carbon atom, and this in turn will attract another monomer, and again the free radical will be transferred to the terminal of the intermediate compound, and more monomers are added. And that's why this is called the chain growth, because the chain is growing in length, is increasing in length. This is polymerization of ethylene. Termination. Termination, this is the last step in the polymerization reaction, where the reaction is terminated and the polymer is formed. So this is the third and final step of the chain growth polymerization. Usually radicals, what happens exactly that as radicals exist, they are unstable. So they will try to find a way to become paired without generating a new radical. So as more monomers are added, a longer free radical is formed, but this free radical is searching for a way to be paired without generating a new radical to become stable. This process is called termination, and this termination is one of two types. Can be by coupling, and coupling will produce longer polymer, or by disproportionation, and this will provide two types of polymers which are shorter. Termination by coupling, it happens when two ground chains find each other. And when they find each other, the two unpaired electrons will come close to each other and then join to form a pair of electrons. Once a pair of electrons is found together close to each other, there's a chemical bond. New chemical bond is formed, which will join the chain, the two chains. So this is a growing chain, and this is another growing chain. When they find each other, the one radical from here will come to join the other to form a bond. The new chemical bond is formed, which leads to the formation of a polymer, which is, of course, longer than its original, which of course longer than its original paired chain. While the termination by disproportionation, two growing chain ends come close to each other. But in that way, one hydrogen of one chain will be attracted to the free radical to form a carbon-hydrogen bond, and the other chain will have two radicals, which will form a double bond. And of course, these two polymers will be less in length, will be smaller in length than the one that is formed by coupling. Two free radical chains found each other. And then one of them will take one hydrogen from the carbon that is next to the free radical. And this hydrogen will come to the free radical and form a hydrogen bond here. Carbon-hydrogen bond. Carbon-hydrogen bond. And this is a saturated polymer. Once this saturated polymer is formed, it will leave the other chain with two carbons, each with a radical, with an unpaired electron. These two unpaired electrons will form a double bond here. And this will come at the end with an unsaturated polymer. So by this proportionation, we will have two types of polymers, one saturated and one unsaturated, and they are shorter in length than the polymer that is formed by coupling. And to wrap up what we have today, we talked about the steps of the addition, the free radical addition mechanism of polymerization. And the initiation first is carried out or is started by an initiator, which form which bind to the monomer to form a new compound, an intermediate free radical. This intermediate free radical will start the propagation step. This initiation can be by radiation, can be by chemical species as an initiator, or thermal initiation by temperature. Thermal initiation, uh, like styrene, so it usually it's stored with a scavenger of free radical. The propagation is the longest step in the mechanism of addition free radical polymerization because this is the lifetime of the polymer formation. In this step, the free radical intermediate compound that is formed by initiation will start to attack a monomer, which in turn will form a longer intermediate compound and which will attack another monomer and so on. And the chain growth take place. This this addition will stop, addition of more monomers will stop by one of two ways. Either there is no monomers in the medium, and this is called the living polymerization because the polymerization is alive as long as we still have monomers. Another way of termination is by termination, and this termination can be by coupling or by disproportionation. So coupling, the two chains will come and combine together, forming a new bond between them. By disproportionation, each two chains come close to each other, but instead of coupling, one of the hydrogen atoms of the carbon next to the free radical will go and join that one of the chains, so it will form a saturated polymer, and leaving the other chain with two radicals with two unpaired electrons. These two unpaired electrons will form a double bond, and in this case, we will have two types of polymer, a saturated and unsaturated polymer. This is the free radicals, very easy. Initiation, propagation, and termination. Thank you guys for watching and see you in the next video.